lovely people, welcome back to my channel. My name is Abdul Malik. You can call me Experience One. Today we are going to look at ABG, acid-base balance, or arterial blood gas. In fact, this particular topic is very important in the NCLEX exams. Students find it difficult to answer them whenever they find it in the questions. And then today we are going to look at the very simplest method how we can be able to analyze them when we have them in the questions. Please, if you have not yet subscribed, kindly subscribe. You like and you share. This is very important. Today, let's look at ABG. ABG. In order to solve acid-base disorders, it is important to know the normal values. Now, when it comes to the normal values of the ABGs, you'll be able to know what the pH, the carbon dioxide, and the bicarbonate. This play a major role. Okay, so we are going to look at this particular, the ranges for us to be able to solve it correctly. Why am I saying so? Because now, when you look at the pH, if the acid-base balance is okay, it's going into the acidic way, then you know that the patient is having what? Acidosis. And then if it is also moving higher, then it tells you that the patient is also going into what? Alkalosis. This particular very, very important, especially when it comes to the pH. Let's look at the normal values for us to be able to analyze them carefully. Okay, now the normal range for pH is 7.35 to 7.45. 7.35 to 7.45. Now, aside having the 7.35 to 7.45, you know, when it comes to the pH, to my own analysis, okay, I've been able to come out with absolute pH. Now, the absolute pH is very important in the NCLEX exams, especially when we want to analyze the acidosis and then alkalosis. The absolute pH is the one that stands in between. Okay, so anything below it is going into what? Acidosis. And then anything above it is what? Is heading towards alkalosis. Now, what is the absolute pH? Is 7.40. Now, absolute pH is 7.40. So any form of pH going below, whether 7.39, okay, going downwards, it tells you the patient is going into acidosis. And then anything from 7.40 above is heading towards alkalosis. This is very important. Okay, and then also we have the CO2, which is the carbon dioxide. Okay, it ranges from 35 or 35 to 45. Okay, 35 to 45. And then when it comes to the bicarbonate, ACO3, it ranges from 22 to 26. 22 to 26. Now, what to check first in ABG is the pH. Okay, because the pH will help you know whether it is acidotic or it is what in an alkalotic side. So this is also one of the things that you have to look at. Now, aside having these normal ranges, we have to also look at it whether it is respiratory or the problem is what is as a result of what? Respiratory problem, or it is as a result of what? Metabolic problem. Okay, now, if the pH and the bicarbonate move in the same direction, please take note of this. The reason why this method is very simple and it is different from the tic-tac-toe that you use, okay, this is very different. So if you want to analyze this particular, if you want to use this particular method very well, then you have to ignore the CO2 here, okay, because everything that we are going to look at here, we are going to ignore the CO2. Though the CO2 can will be represented, okay, in the values, but we are going to ignore it. We are going to use the pH and then the bicarbonate to analyze the metabolic and then the respiratory. So please, this is very important, okay, whilst we move on. So if the pH and the bicarbonate move in the same direction, then the acid base is metabolic. Please listen to this very carefully. If the pH and then the bicarbonate moves in the same direction, it tells you that it is metabolic. Why? So that means that if the pH is going high and the bicarbonate is also going high, then we say the acid base is metabolic. At the same time, if the pH is going low and then the bicarbonate is also going low, then we say that the acid base is what? Metabolic, because they are moving in the same direction. Now, how about respiratory? Whenever the pH and then the bicarbonate is moving in opposite direction, then the acid base is respiratory. Please try and understand this, because this method is the simplest method. Okay, and then it has about 99.9% pass what chance. So please Try and understand it. Okay, so if the pH and the bicarbonate is moving in opposite direction, then the acid base is respiratory. This is also one of the things that we can help us to analyze the acid base. Now let's take an example. Now when you take the example 1, pH is 7.22, bicarbonate ACO3 is 20. Now let us analyze this. Now when we want to look at the pH to know whether it is acidosis or alkalosis, we said that we have to use the absolute pH, which is 7.40. So anything below 7.40 is going into the acidosis side. Now if you look at the pH here, which is 7.22, that should tell you that it is what? Acidosis. So now we have our acidosis. All right. Now how can we determine whether it is respiratory or metabolic? And then we said that when it is moving in the same direction, it is metabolic. Okay. Now when you look at the pH and the bicarbonate, you see that the bicarbonate is going low, whilst the pH is also going low. So it is what? Metabolic. In this case, we have metabolic acidosis. Metabolic acidosis. Let us look at example 2. pH is 7.50. pH is 7.50. Bicarbonate is 30. Bicarbonate is 30. Now, when you look at this, you know, the pH has gone beyond the absolute pH, which is 7.40. So it is alkalosis, right? Yes, now we have our alkalosis. How can we determine whether it is respiratory or metabolic? Now, when you look at the ACO3, which is the bicarbonate, the normal range is 22 to 26. Now, the ACO3 is 30 here, which is going high. At the same time, the pH is also going high. So, since they are moving in the same direction, the acid base is what? Metabolic. So, we have metabolic alkalosis. I'm sure you are understanding this particular method well. Now, let's look at another example here. The third example, pH is 7.20. pH 7.20. ACO3 35. ACO3 35. Now, 7.20 is below the absolute pH, which is 7.40. It's below 7.40. So we know it's acidosis. So we have our acidosis there, which is 7.20. Now, the bicarbonate is also 35. The normal bicarbonate is 22 to 26. Now, 35 is high. So you see that the pH and then the bicarbonate is moving in opposite direction. Whilst the pH is going low, the bicarbonate is going high. So in this case, we have respiratory because they are moving in opposite direction. And then since the pH is acidosis, we said we have respiratory acidosis. Respiratory acidosis. I'm sure you are following. Okay. Now, the last example here is pH, which is 7.55. pH, which is 7.55. And then bicarbonate, which is 18. Bicarbonate is 18. Since the pH and the bicarbonate are moving in opposite direction, then we have what? Respiratory. And then the pH is 7.55, which tells you that here, in this case, the pH is going in opposite direction with the bicarbonate. So we have what? Respiratory. So in this case, we're going to have respiratory alkalosis. This is very, very important. So this is the first method for the acid-base balance. I'm sure you are following, all right? Now, how can we determine whether it is what? Compensated, uncompensated, and then also partially compensated? This comes to the next chapter, part 2. So please stay tuned whilst we bring you the next part. Have a nice day. Bye-bye.